inside the teenage brain understanding development decision-making. Ever wondered why teenagers act the way they do? Today we're diving into the fascinating world of teenage brain development. 1. Brain development basics. During adolescence, the brain undergoes significant changes that shape behavior, emotions, and cognitive abilities. Here are the key changes that occur. 1. Pruning. During childhood and adolescence, the brain undergoes a process called synaptic pruning. This involves the elimination of unnecessary synapses connections between neurons that were formed earlier in life. Pruning allows the brain to become more efficient by strengthening important connections while eliminating weaker ones. This process is influenced by genetics, experience, and environmental factors. 2. Myelination. Myelin is a fatty substance that forms a protective sheath around nerve fibers' axons in the brain. During adolescence, there is a significant increase in myelination, particularly in areas of the brain responsible for higher-order thinking, decision-making, and emotional regulation. This increase in myelination helps to speed up communication between neurons, enhancing cognitive abilities. 3. Synaptic connections. Synaptic connections, which are the junctions between neurons where information is transmitted, undergo refinement and strengthening during adolescence. While some synapses are pruned away, others are strengthened through a process known as synaptic consolidation. This process enhances neural circuits involved in skills such as learning, memory, and social cognition. 4. Prefrontal cortex development. The prefrontal cortex, located at the front of the brain, undergoes significant development during adolescence. This region is crucial for decision-making, planning, impulse control, and weighing consequences. As adolescents mature, connections between the prefrontal cortex and other brain regions become more efficient, allowing for better regulation of emotions and behaviors. 5. Hormonal influences. Hormonal changes during puberty also play a role in brain development. Hormones such as estrogen, testosterone, and cortisol influence neuronal activity, synaptic pruning, and myelination processes. These hormonal changes can affect mood, social behavior, and cognitive functions during adolescence. Understanding these key changes in the adolescent brain helps explain why teenagers may exhibit behaviors such as increased risk-taking, emotional volatility, and heightened sensitivity to peer influence. It also underscores the importance of providing supportive environments and positive experiences during this critical period of brain development. 2. Impact on behavior. Adolescent changes in the brain significantly influence teenagers' behavior, emotions, and social interactions. Here's how. 1. Behavior. Risk-taking due to ongoing development in the prefrontal cortex responsible for decision-making and impulse control and heightened sensitivity to reward. Teenagers are more prone to engaging in risky behaviors such as experimenting with drugs, reckless driving, or thrill-seeking activities. Sensation-seeking. The increased activity in the brain's reward system during adolescence can lead teenagers to seek out novel and exciting experiences more frequently than adults. This drive for novelty can influence their choices in friendships, hobbies, and activities. Peer influence. Adolescents are particularly sensitive to peer influence due to the development of brain areas involved in social cognition. They may conform to peer norms, take more risks in the presence of peers, and prioritize social acceptance and belonging. 2. Emotions. Intense emotions. Adolescents often experience heightened emotional intensity, characterized by rapid shifts between happiness, sadness, anger, and frustration. This emotional volatility is partly due to the development of brain regions involved in emotional processing, such as the limbic system. Stress response. The hormonal changes during puberty, coupled with ongoing brain development, can influence how teenagers perceive and respond to stress. This period can be marked by increased sensitivity to stressors and varying coping mechanisms. 3. Social interactions. Peer relationships. Adolescents place a high value on peer relationships as they navigate social hierarchies, identity formation, and independence from caregivers. brain changes related to social cognition and empathy development play a crucial role in forming and maintaining friendships. Parental relationships. While peers become increasingly influential, parental relationships remain vital during adolescence. Changes in the brain's reward system and emotional processing contribute to shifts in parent-teen dynamics, including conflicts over autonomy and decision-making. Overall, the interplay between brain development, hormonal changes, and social experiences during adolescence shapes behavior, emotions, and social interactions in profound ways. Understanding these influences can help adults, caregivers, and peers provide support and guidance that aligns with teenagers' developmental needs. 3. Decision-making challenges. Teenagers' engagement in risky behaviors and struggles with impulse control can be attributed to several interconnected factors influenced by their developing brains and social environments. 1. Brain development. Prefrontal cortex immaturity. The prefrontal cortex, responsible for decision-making, impulse control, and weighing consequences, undergoes significant development during adolescence. However, it matures more slowly compared to other brain regions. This delayed development can lead to adolescents having difficulty in inhibiting impulsive behaviors and making sound judgments. Heightened sensitivity to rewards. During adolescence, there is increased activity in the brain's reward system, particularly the nucleus accumbens. This heightened sensitivity to rewards can lead teenagers to seek out novel and stimulating experiences, even if they involve risks. The anticipation of rewards can override considerations of potential negative outcomes. 2. Social and environmental factors. Peer influence. Adolescents are highly influenced by their peers as they navigate social acceptance and identity formation. Peer pressure can encourage risky behaviors as teenagers seek approval, acceptance, or validation from their peer groups. Societal expectations and media influence. Cultural norms and media portrayals can glorify risk-taking behaviors or portray them as normative among adolescents. This can influence teenagers' perceptions of what is acceptable or desirable behavior. Family dynamics. Family environments, including parenting styles, communication patterns, and levels of supervision, can influence adolescents' risk-taking behaviors. Lack of parental monitoring or inconsistent discipline may contribute to increased risk-taking. 3. Biological and hormonal changes. Pubertal hormones. Hormonal changes during puberty, such as fluctuations in testosterone and estrogen levels, can affect mood, impulsivity, and sensation-seeking behaviors. These hormonal shifts may contribute to heightened emotional reactivity and risk-taking tendencies. 4. Cognitive and emotional factors. Limited experience. Adolescents often lack the life experience and cognitive maturity to fully assess risks and consequences. They may underestimate potential dangers or believe they are invulnerable to negative outcomes, a phenomenon known as adolescent invincibility. Emotional intensity. Adolescents experience intense emotions due to ongoing brain development and hormonal changes. These emotions can influence decision-making processes and increase the likelihood of impulsive behaviors in response to emotional triggers. Understanding these factors helps to contextualize why teenagers may engage in risky behaviors and struggle with impulse control. It underscores the importance of supportive environments, positive role models, and opportunities for learning and growth during this crucial stage of development. Several scientific studies have explored how brain development influences decision-making in teenagers, shedding light on the cognitive and neurobiological processes involved. Here are some key findings. 1. Prefrontal cortex development. The prefrontal cortex (PFC), particularly the dorsolateral prefrontal cortex (DLPFC) and ventromedial prefrontal cortex (VMPFC), undergoes significant development during adolescence. These regions are crucial for higher-order cognitive functions such as decision-making, impulse control, planning, and reasoning. Study example. Researchers like Sarah Jane Blakemore and colleagues have conducted neuroimaging studies showing that the PFC continues to mature into early adulthood. They found that during adolescence, there is increased activation in the PFC during decision-making tasks, suggesting ongoing refinement of cognitive processes related to risk assessment and reward processing. 2. Reward system sensitivity. The brain's reward system, including the nucleus accumbens and ventral striatum, shows heightened sensitivity during adolescence. This sensitivity contributes to adolescents' increased motivation to seek rewards and engage in novel or risky behaviors.